So how do you get an AI to stop just thinking and actually start doing stuff in the real world? To solve problems not just inside its own digital mind, but out here with us. Well, today we're going to look at a pretty groundbreaking method that's teaching AI to combine reasoning and acting in a way that, honestly, looks surprisingly human. All right, let's get into it.
But first, let me ask you something. When you're up against a totally new problem, I don't know, maybe you're trying to build some crazy piece of IKEA furniture or you're winging it with a new recipe, how do you actually solve it? You don't just stare at the pieces and have the answer magically appear, right? No, there's a process, a little loop your brain runs, almost without you even realizing it.
And it probably goes a little something like this, right? You start with a thought. Okay, I need salt for this. That thought makes you do something, an action. You go and open the kitchen cabinet. Then you observe what happens. Whoops, no salt in here. And that observation, that new piece of information, forces you to rethink. All right, change of plans, I'll just use soy sauce instead. That little cycle, think, act, observe, rethink, that's the secret sauce to how we navigate a world that's constantly throwing us curveballs.
Now, here's the thing. For the longest time, AI just didn't work like that. AIs were specialists. You had models that were fantastic at thinking, and other models that were great at doing. But getting one to do both at the same time? That was a huge problem. It was a real dilemma.
It was like having two different characters. On one side, you had the thinker. This AI is brilliant at planning things out step by step, what we call a chain of thought. But the problem is, it's totally stuck in its own head. It has no connection to the real world, which means it can just start making things up, what researchers call hallucinating. Then, on the other side, you've got the doer. This AI is awesome at actually interacting with things, using tools, moving around. But it has no high-level plan. It gets stuck all the time, just trying the same failed action over and over again like a broken record.
And here's a perfect example of what goes wrong with a thinker. When it was asked a pretty simple question, it came back with this super confident fact about Apple products. There's just one tiny problem. It's totally wrong. The AI just invented a plausible-sounding connection in its own little world, and that led it to a completely wrong answer.
And then you have the doer, which has the exact opposite problem. Look at this. In a simulation, it was told to get a pepper shaker. It decided the pepper shaker was in the sink. It wasn't. But instead of thinking, maybe my plan is wrong, it just kept trying and trying and trying the same failed action. It was doing things, sure, but it wasn't learning from what was happening.
Okay, so this is where a totally new approach called ReACT comes into the picture. And the name is actually pretty clever. It's a mix of its two main jobs, to reason and to act. So what is it really? Well, in a nutshell, ReACT gets an AI to kind of talk to itself. It makes the model generate its reasoning, its thoughts, and then immediately generate an action based on those thoughts. It weaves them together, so it's not thinking and then doing, it's thinking while it's doing.
And this is the core loop right here. The AI has a thought, like, okay, first I need to find out what X is. That thought leads to an action, maybe searching a website. Then it gets an observation back, the result of that search. And that new info feeds its next thought. Does that sound familiar? It should, because that's pretty much exactly what we talked about at the beginning, right? It's the human loop.
And that's the magic right there. It's this beautiful synergy. The AI's thoughts help it come up with smarter actions, and the actions, by actually checking things in the real world, keep its thoughts grounded in reality. They stop it from just making stuff up. Each part makes the other one better.
Okay, that all sounds great in theory, but does it actually work? Let's take a look at how it did when they put it to the test.
So the researchers decided to throw ReACT the exact same curveball that stumped our thinker model earlier. That question about the Apple remote. But this time, they gave the AI a tool it could use, a simple Wikipedia search.
And you can literally watch its thought process unfold here. It starts with a thought, I should probably search for Apple remote. So it takes an action. It searches. The observation it gets back is that the remote was for something called front row. That new fact sparks its next thought. Okay, so what's front row? Which leads to another action. You see how it's building on real information step by step to get to the right answer? And boom, success. Just by being able to reach out and check its facts against a real source of information, ReACT totally sidesteps that hallucination problem that trapped the thinker. It didn't have to guess or invent an answer. It could actually find out for sure. And that is a huge deal.
And we're not talking about a small improvement here. The performance gains are, well, they're just huge. In a really complex task where an AI has to navigate a simulated house, ReACT hit a 71% success rate.
The next best was way down at 45%. That's a 34% absolute jump over the previous state of the art. It just completely blows the other methods out of the water.
So yeah, React gets better scores, but honestly, that's not even the most exciting part. The real implications here go so much deeper than just winning a competition. So let's break down the big advantages. First, it's way more trustworthy because you know its answers are based on real facts it looked up. Second, it's more interpretable. We can actually follow its line of thinking. And maybe the most mind-blowing part, it's controllable by us, by humans.
I mean, think about it. For the first time, we can actually pop open the hood and see the AI's thought process. We can understand why it made the choices it did. This is such a massive step away from the whole black box problem, where we just had to trust the AI's output without knowing how it got there. Now we can see the work.
And this quote from the paper is where things get really wild. Because we can read the AI's thoughts, we can also edit them. If you see the AI's reasoning is a little off and it's about to make a mistake, you can actually step in, correct its thought, and steer it back in the right direction. This opens up an entirely new way for humans and AI to collaborate on solving problems.
Which brings us to a really big final thought. We now have a blueprint for an AI that can think, act, observe, and learn, a lot like we do. It's more trustworthy, we can understand it, and we can even guide it. So the question isn't just, what can AI think about anymore? The real question is, what should we ask it to do next?